Shanika, Sriyuta. Good evening, all.
Good evening, sir.
Shanika, this is the first class.
Yes, sir.
Okay, so in which college you used to study, ma?
NPS Yashwanpur.
A little bit louder.
NPS, sir.
NPS, National Public School.
Yes, sir.
Okay, so am I in Hyderabad only, yeah? Which location? Area.
Yashwanpur.
Yashwanpur, you're from Bangalore.
Yes, sir.
Okay, so that's why I got a doubt because of in NPS in Bangalore only it is there. I don't know when they started in Hyderabad. That's why I'm asking.
Yes, sir.
Okay, so then you are from Bangalore. Then no problem. So Shanika, yesterday we started some basic concepts of chemistry. Okay, just small introductions or just a brief introduction I had given. Okay, so Shanika, are you preparing for NEET or JEE, ma?
JEE, sir.
JEE, very good, ma. Okay, so on related here, so based on the JEE, from some basic concepts of chemistry, if you check it out, previous year papers means every year they ask one question from the some basic concepts of chemistry. And that is also I'm not touching all the corners because we don't have that much of time. Okay, so due to that reason only, exam point of view, important concepts are going to be discussed in this class. Okay, in last class we discussed about the law of chemical combination. Okay, if you wanna check it out, means better to go through briefly that video, yesterday's video. Yesterday video is available in the app here. Okay, you can see that video also. If you're having any doubt under told me, just you can contact, you can call. Okay.
Yes, sir. I have watched it.
Okay. Next. Good. So do you understand the concept, yesterday concept?
Yes, sir.
Okay, then fine. So Sriyuta.
Yes, sir.
So yesterday I forwarded some assignment. Have you checked or not?
Yes, sir. I completed and submitted the assignment and I also did the test.
Very good, ma. Very good. Very good. Okay. Next. So today we are going to discuss. I don't want to waste our time because of generally daily we are getting as just 40 minutes of the time. In that 40 minutes of the time, we have to cover a little bit important concepts. Okay. So hope so. So they'll join slowly. Already I texted them. Okay. Now, so today we are going to discuss about mole concept. Okay. So mole concept is very, very important concept here. Okay. So mole concept. Mole concept. Okay. I think so. You already studied this one about this one. Okay. So mole concept is interlinked almost all 3 chapters. So what are the 3 chapters are interlinked to the mole concept? Any one of you? So where it is going to be interlinked mole concept? Whole chemistry only, it is related to the mole concept only. Every time we are calling as a number of moles, number of moles, number of moles. Okay, is that clear? So because of here mole concept is related to some basic concepts of chemistry and continuation chapter redox reactions are there. Okay, and solutions chapter in 12th standard we are going to study about the solutions chapter. So that is also it is interlinked to the mole concept. Okay, so first of all, what is mean by the mole? So what is mean by the mole means here? So mole is nothing but it is a SI unit. It is also SI unit. Mole is SI unit. Okay, like kilogram, like kilometer. Okay, so kilogram is nothing but SI unit of the weight only, na. Kilometers are nothing but so SI unit of the distance only, na. And length means how you're calculating my SI unit. Length. What are the units of the length in SI?
Meter.
Meter. Okay, so here kilogram, meter. Okay, so kilometer. So however SI units are there, so like that, so we have a mole is nothing but it is a SI unit. And like dozen, so what is meant by the dozen? Dozen means it contains how many number of units are there?
12.
12 units are there. So like that only, 1 mole of any substance it contains Avogadro number of atoms or molecules or ions. Okay, so what is meant by the mole means a mole is nothing but it is the SI unit. Okay, so 1 mole of any substance, it contains Avogadro number of, okay, it contains here Avogadro number of, what is Avogadro number? Avogadro number can be represented with Na. Okay, so what is Avogadro number value?
6.023 into 10 to the
Very
power
good.
23.
6.023 into 10 power 23. Okay, it contains 6.023 into 10 power 23 number of atoms are there. Okay, molecules. If you take molecules means it contains here molecules are there. Okay, and ions also it will be there. Any substance, if you take means 1 mole of any substances contains how many number of entities means it contains Avogadro number of entities. What is with Avogadro number means 6.023 into 10 power 23 number of atoms or molecules or ions it contains. Okay, now so 1 mole of any substance, if you take atoms means 1 mole is equal to their gram atomic weight. Their gram atomic weight here. So 1 mole is equal to the gram atomic weight. So we can write as here gram atomic weight. Okay, and so 1 mole of any substance is equal to, if you take the molecule means it is equal to the gram molecular weight. Gram molecular weight. Gram molecular weight here. Okay, and so 1 mole of any substance at STP conditions, STP, what is with the STP? STP is nothing but standard temperature and pressure na? Okay, so sometimes to make you confused they'll write as a NTP also. Okay, sometimes they to make you confused they'll write as a NTP also. Okay, so NTP is nothing but normal temperature and pressure. So 1 mole of any substance, okay, at STP condition, that means gases, 1 mole of any gas at STP conditions, it occupies 22.4 liters of the volume. 22.4 liters of volume. 22.4 liters of the volume. If you convert into the ml formation, 1 liter is equal to how many ml? 1 liter is equal to how many ml, ma?
1000.
1000 ml, Samhita. Very good, ma. Okay, so that means 22.4 liters we can convert into the ml form means how we can write? How we can write? 22,400 ml. So ml formation means 1 mole of any gas, it occupies 22,400 ml of the volume at STP condition. Okay, so now you got the clarity, all of you here. Okay, and moles can be represented with the small n. How we are going to represent my here? So mole is represented as a small n. Okay, so number of moles. How we are going to calculate the number of moles means here given weight by gram molecular weight. If you take here, if you take the atom means here gram atomic weight also we can take. Okay, or if you are taking the molecule means we can take as a gram molecular weight also we can take. Okay, if it is the atom is for that one we can calculate this as a gram atomic weight. If it takes a molecular weight means that we can call as a gram molecular weight. Okay, so now all of you got the clarity what is meant by the mole and how we are going to calculate the number of moles. Okay, so can I give 2 examples how to calculate the number of moles here?
Yes.
Samhita. Right now. Ishanika, do you understand here until here?
Yes, sir.
Okay. Then no. Yeah. So one question, ma. So already you got the formula. So what is the formula means here? So how to calculate the number of moles means number of moles can be calculated by using N is equal to given weight by gram molecular weight. Okay. So 2-3 questions just I'll ask me here. 8 grams of the oxygen gas is equal to, okay, calculate or convert 8 grams of the oxygen into number of moles. Convert 8 grams of oxygen gas into number of moles. So what is the answer, ma?
0.25.
0.25. Very good, Samhita. So how we calculate the number of moles? Means number of moles is equal to, okay, number of moles is equal to how much here? So given weight. How much weight they had given? 8 grams. What is the molar mass of the oxygen?
32.
32, ma. We had taken as a molecule. So molecular mass of the oxygen is equal to 32. So 32 means you will get as a 1/4 only, na? 8 ones, 8 fours. So 1/4 value you will get as a 0.25. So 8 grams of the oxygen is equal to how many moles? Means we can take as here 0.25 moles. Okay. Now you got the clarity. I'm a same question. So one more method I'm asking here. 8 grams of the oxygen, it occupies how much volume at STP conditions? Ishanika, the question is for you.
Yes, sir.
Okay, at STP conditions, 8 grams of oxygen, it occupies how much volume?
22.4 liters volume.
Ma, I'm asking here 8 grams of the oxygen.
Into
8 grams of the oxygen, ma.
into 8, sir.
Ma?
22.4 into 8 actually.
No, ma. My question is the volume occupied by 8 grams of oxygen. 8 grams of oxygen. So this is the question here. Okay. Sir, how we can calculate means first of all, they are given as oxygen gas. They are given as a oxygen gas. What is the molar mass of the oxygen gas here? 32 grams. So 32 grams is equal to 1 mole. 32 grams is equal to 1 mole means 1 mole of gas at STP condition, it occupies how much volume? Means 22.4 liters of the volume only. Na? How much volume? 22.4 liters of the volume. Okay. Now they are given, they are asking 8 grams of the oxygen, it occupies how much volume? So if you consider it as an X, and if you do the cross multiplication, if you do the cross multiplication means you will get the answer. If you do the cross multiplication means you will get the answer. So if you do the cross multiplication and tell me the answer, ma. Any one of you?
5.6.
5.6 is the correct answer, ma. Okay. Ishanika, you got the clarity?
Yes, sir.
So 32 into X is equal to 22.4 into 8. Then X is equal to 22.4 into 8 divided by 32. 8 ones, 8 fours. 4 ones, 4 fives, 0.6. Then how much volume it occupies means 5.6 volume. 5.6 liters of the volume it is going to be occupied. Now you got the clarity? Still anyone you are having doubt? Okay. Clear? Based on, if you see 2019 paper and 2020, recently 23 paper also, ma. Okay. They asked some questions. How many number of atoms are there? They had given some molecules and they had given some masses. So which of the molecule is containing the highest number of the atoms? Related that one, that kind of question, one question I'll ask my here. Okay. Now let's see. Now my question is, next another question, let's see who's going to give the answer. Okay. 44 grams of carbon dioxide. The number of atoms present in 44 grams of the carbon dioxide. The number of atoms. The number of atoms present in 44 grams of carbon dioxide gas? Any one of you?
So 6.023 into 10 power 23.
6.023 into 10 power 23. Is that the answer? Otherwise, can I give some options to you?
Yes, sir.
Okay, ma'am. So I'm giving the options here. Option A, Avogadro number. Option B, 2 into Avogadro number. Option C, 3 into Avogadro number. Option D, 4 into Avogadro number.
Option is
Option? Samhita is guessing option A. Ishanika.
A, sir.
Ishanika also A. Next.
A, sir.
Ma?
A.
Samhita is A. Ma, so can I give the clarity here? First of all, once you check it out, ma. Carbon dioxide is the molecule, ma. It's not the atom. One carbon dioxide molecule is containing one carbon atom plus 2 oxygen atoms. The total number of atoms is equal to 1 mole. Na? 1 mole of any substance. Carbon dioxide is containing the 3 atoms means here, then 3 into Avogadro number. Na? It is the 3 into Avogadro number. Ma. Into Avogadro number. Clear? Still anyone you having doubt? Anyone you having doubt? It is very, very important. Ishanika, can I give one more question to you
Yes, sir.
to make you clarity, Sriyuta? Okay.
No
Can
doubt,
I-
sir.
Amma, Sriyuta? Sriyuta, you are
No
asking.
doubt, sir.
No doubt, na? Okay. Right, ma. So this kind of questions are there, ma. So clearly I had seen. Okay, if you want to check it out, means once you check it out the previous year papers also. Okay, so this kind of questions are there. And one more question they ask here: the number of electrons present in, sir, 14 grams of the nitrogen. Any one of you. The number of electrons present in 14 grams of nitrogen. The number of electrons present in 14 grams of the nitrogen gas. Clearly, it is the question. The total number of electrons present in.
So 2Na?
Number of electrons, ma. All of you having idea about the structure of atom, na? But this question also, it is the previous year question only, and that is also JEE question, this one here. Okay. Now, I'm asking the question is here, number of electrons present in 14 grams of nitrogen gas. That is the question actually. Okay. This is the question. Now, first of all, I would like to ask one thing here. What is the atomic mass of nitrogen molecule? Nitrogen can be exist in a molecule. What is the molecular mass of the nitrogen?
14.
Molecular mass, ma. I'm not asking the atomic mass.
28.
28, ma. Molecular mass is equal to 28. But question is they had given us a 14 grams. First, we can calculate the number of moles. Number of moles is equal to given mass by molar mass. Given mass by molar mass means 14 ones, 14 twos. That means you'll get as a 0.5 moles. Okay, how many moles it is there? 0.5 moles. Now we got the clarity, all of you. Okay.
Yes, sir.
Right, ma'am. And one more question. First, I am taking as a one nitrogen atom. What is the atomic number of the nitrogen?
7.
7. Any atom, it contains the equal number of neutral atom is contains the equal number of electrons and equal number of protons. Na? Is that clear? Is that clear, everyone?
Yes.
Yes, sir.
Yes, sir.
Okay. So it contains equal number of electrons and equal number of protons. Like that here, if you tell one nitrogen atom is containing 7 electrons means, then what about the nitrogen molecule? The total number of electrons present at nitrogen molecule, ma. All these are the basic questions, ma. Fundamental concept, this one. Very good, ma. Ma here 14. So according to that one, 28 grams of, I'll write that clearly here. So to make you clarity, 28 grams of nitrogen gas is contains 14 into Avogadro number of electrons. 14 into Avogadro number of electrons. Ma, 28 grams is equal to 1 mole. Clearly already. So 1 mole of nitrogen gas is containing here. So 14 into Avogadro number of electrons are there. Then what about the 0.5 moles of the nitrogen gas? What about the 0.5 moles of the nitrogen gas?
7 Na.
Ma,
7 Na.
7 and a very good answer. Suyuta, very good, ma. Okay, so 14 into Na into 0.5. Na into 0.5 also we can write as a 1 by 2. 1 by 2 means 2 ones, 2 sevens. Then what is the answer you will get? 7 Na. Okay, the number of electrons present in 14 grams of the nitrogen gas is equal to 7 into Avogadro number. Sometimes to make you confused, they are writing the calculating value, ma. Calculated value they are giving here. Actually, 7 into 6.023 or 6 into 10 power 23. 6 into 10 power 23 means 7 6 are how much, ma?
42.
42 into 10 power 23. If they give this value also correct only, na? Is they had given 42 into 10 power 23 means either it is the correct answer or not?
Yes, sir.
Okay, so this kind of questions are there in JEE. Okay, now we got the clarity, all of you.
Yes,
How
sir.
to calculate number of moles, number of gas, okay, number of atoms, number of molecules. I think so. Every model I showed one question. Every model I had given one calculation part. Okay, at the same time, number of moles we are using in the concentration terms also. Okay, so where we are using as the number of moles means here in concentration terms we are using. So what is meant the concentration terms, ma? Concentration terms. What are the concentration terms we are using? Concentration terms. Number of moles also it is there.
Molarity.
Chanakya. Chanakya correct only, ma. You are giving what are the answers you are giving correct only. Concentration terms. Concentration terms. Okay. So what are the concentration terms? What is meant by the concentration means? So actually it is related to the solution. Solution is nothing but it is a mixture of components. Solution is related to the mixture of components. Okay, solution is containing more than one component here. So that mixture only we can call it as a solution. Okay, in this one, we are going to explain the concentration term. What is meant by the concentration term means here? Actually, solute is containing two components. One is the solute, another one is the solvent, which we can call as a solute. The substance which is present in a lower quantity is called as a solute. Okay, another one we can call as a solvent. So the substance which is present in a larger quantity is called as a solvent. So based on the solute and solvent, we are going to be explain the concentration. Okay, in a solution, if the solute content it will be less and solvent content it will be more. Okay, or how we can define the concentration means here the maximum amount, the amount of solute present in a solvent can be represented as a concentration, because we have two types of the solution: dilute solutions and concentration solutions. What is meant by the dilute solutions, ma? What is meant by the dilute solution?
Less amount of solute.
Dilute solution means water it will be more.
Yeah, less amount of
Solvent content it will be more, solute content it will be less here. And concentrated means here, what is mean the concentrated solution?
More amount of solute.
Very good, mark. Solute it will be more and solvent content it will be less. That kind of solutions are we can call as a concentrated solution. Okay, and we have a different types of the concentration terms. What are the concentration terms we are having means here? Weight by weight percentage. Okay, or this also we can write as here mass by mass percentage also. Mass by mass percentage. Mass by mass percentage, how we can define ma? So mass of solute present in mass of solvent. Mass of solvent. So mass by mass percentage. Percentage means we have to multiply with 100. Okay, so 100 mass. So now you got the clarity here. So mass of the solute present in here, mass of the solvent. Okay, and weight, mass by volume percentage, or weight by volume percentage. So here mass of the solution, my here. Downside is here mass of the solution. It's not the solvent here. Mass of solution. Okay, here weight by volume percentage. So what is the weight by volume percentage here? Weight of solute present in 100 ml of solution. 100 ml of solution. Today I'm going to write as a formulas. Tomorrow we are going to calculate. We are going to do some of the calculation based on this one, and that is also tomorrow we are going to do some previous year questions. Okay. Today simply I'll write the formulas first. Just while coming tomorrow, you have to learn all these formulas and terms. Okay, clear?
Yes, sir.
Yes, sir.
Right now. So this is the weight by volume percentage. And what is another one here? So weight by weight percentage and weight by volume percentage and volume by volume percentage. Volume by volume percentage, how we can define here? So volume of the solute, volume of solute present in 100 ml of solution. So percentage means we have to multiply with here 100. Okay, and parts per million, ppm. So ppm is nothing but here parts per million. So how we can define the parts per million means here mass of solute present in mass of solution into 10 power 6. Okay, sir, where we are using as a mass for parts per million? Sometimes they're asking the question here. So parts per million units can be used to represent pollution of the air and pollution of the water also. Okay, so where we are using as a parts per million means here. So parts per million can be used to represent air pollution and water pollution. Okay, clear? Next, and here only we have another one here, mole fraction. So what is meant by the mole fraction? What is meant by the mole fraction, ma? How we are going to represent the mole fraction? Now again here you got as a mole fraction, interlink. Mole fraction can be represented with chi, or sometimes we can call it as X also here. Okay, mole fraction can be represented with here chi or x also. Okay, so we are talking about the binary solution. Binary solution means the solution is containing the two components. How many components are there in a solution? Two component. For example, we are considering as a xa and xb are the components. xa and xb are the components. So how we can write the mole fraction of this? Xa means here xa is equal to number of moles of one component by total number of moles of components present in a solution. That means number of moles of the solute plus number of moles of the solvent. Okay, for example, if they ask what is the mole fraction of the xa, how we can represent the mole fraction of the xa means here xa is equal to Na by Na plus Nb, and xb is equal to, how we can write as here, Nb by Na plus Nb. Okay, according to that one here, xa plus xb is equal to 1. xa plus xb is equal to 1. So based on this one, if you know the mole fraction of the one component, means by using that one we can calculate the mole fraction of the another component now. We can calculate or not?
Yes, sir.
Okay, so if you know the mole fraction of the A means by using that one we can calculate the mole fraction of B. Sir, how we can calculate the mole fraction of B means here, how we can write the formula means xb is equal to 1 minus xa. Otherwise, if you know the xb value, you want to calculate the xa value, how we can write the formula xa is equal to 1 minus xb. So this is the formula we are using, and next important formula. So what is the important formula we are having means here, molarity. So what is meant by the molarity, ma? What is meant by the molarity? So molarity can be represented with M. Molarity can be represented with M. Okay. How we can define the molarity means molarity is equal to number of moles of solute, number of moles of solute present in 1 liter of solution. Present in 1 liter of solution is called as a molarity. Okay, so to make you simplify, sometimes they're asking the weight of the compounds here. So to calculate the weight means how we can simplify the formula means molarity is equal to, in place of N. So N we are writing as a weight by molecular weight only now. We are writing as weight by molecular weight. So in place of N directly we can write as a weight by molecular weight. Okay, into 1 by V in liters. V in liters. So V in liters also we can sometimes they are giving as ml formation. If they had given ml formation means how we can write the formula means here weight by molecular weight into 1000 divided by V in ml. V in ml. So by using this formula also we can calculate anything. Okay, we can calculate the molarity, or we can calculate the weight, or we can calculate the molecular weight. Okay, if you know the values means if you substitute in this formula means we can calculate the anything. Okay, now we got the clarity, ma. And one more question, JEE level question they're asking here. Okay, what is the question they're asking means here, is molarity depends upon temperature or not?
Yes, sir.
Is molarity depends upon the temperature. How you are telling that is molarity depends upon the temperature?
So because volume is directly proportional to temperature.
Very good, mark. So volume is directly proportional to temperature. So V is directly proportional to the temperature. So that's why M is directly proportional to, because of M is inversely proportional to molarity depends upon the temperature. Okay, so depends upon temperature. Depends upon temperature. Okay, and so we can write as some continuation formulas here. Resultant molarity experimental based are there. Okay, some other formulas also it is there. So what are the other formulas are there for this one related to M1 V1 here? Some resultant molarity. Okay, so experimental based also volumetric analysis also we are using some formula. What is the formula we are using for the volumetric analysis means here M1 V1 is equal to M2 V2 also. Okay, M1 V1 is equal to M2 V2 formula we can use. Okay, and Another formula what we are using the volumetric analysis means M1 V1 by N1 is equal to M2 V2 by N2 formula also. This formula we are using in a volumetric analysis part. Okay, and what are the other formulas we can use means resultant molarity, some formula is there. MR. Sir, how we can calculate the resultant molarity means when two acids are mixing together or when two bases are mixing together. So how we can calculate the resultant molarity means what is the formula means here M1 V1 plus M2 V2 by V1 plus V2 is the formula. Sir, if they had given us a different formulas, but this one is similar acids or similar bases. But if they had given acid and base, both are acid and base they had given. So what is the formula we are using to calculate the resultant molarity means MR is equal to M1 V1 minus M2 V2 by V1 plus V2 is the formula. Okay, so V1 plus V2 is the formula we are using to calculate the resultant molarity. Okay, and what is the another formula we are using means here molarity and density relation formula. So molarity is equal to X percentage. X is nothing but weight by weight percentage. Okay, X percentage into density into 10 divided by molecular weight of the solute. Molecular weight of solute. So this is the one formula we are using to calculate the density and molarity relation formula. So we have a different formulas. All these different formulas are we are using. And one more concept of also is that. So which is related to the molarity also here. And we can write as a normality. Normality. How we can define the normality, ma? How we can define normality? Any one of you? Normality can be represented with capital N. Normality is defined as number of equivalent weights, number of equivalent weight of solute present in 1 liter of solution. Present in 1 liter of solution. Okay, so this also we can write as here. Okay, how we can write means normality is equal to weight by equivalent weight. How we can calculate the number of equivalents means here weight by equivalent weight. What is meant by the equivalent weight?
Atomic weight by valency factor.
Very good, ma. So atomic weight by equivalent weight is nothing but here R marked by N factor V in ml. Okay, so here how we can define as an equivalent weight means equivalent weight is defined as it is molecular weight by N factor. So based on this one also they are having some question. Previous year question also it is there, especially based on the what is the equivalent weight of the KMnO4? In acidic medium, what is the equivalent weight? Okay, in basic medium, what is the equivalent weight? Okay, in neutral medium, what is the equivalent weight? So that kind of question they're asking my here. Okay. Now once you check it out here. So equivalent weight is equal to molecular weight by N factor. What is the N factor? What we can take? N factor, what we can take? N factor we can take as acidity or basicity, the number of electrons transferred in a chemical reaction, number of electrons transferred in a chemical reaction, number of electrons transferred in a chemical reaction. Flip cut. Number of electrons transferred in a chemical reaction. So based on this one, so we can calculate the equivalent weight. Now we got the clarity. And what are the other formulas we can use here? Resultant normality is equal to N1 V1 plus N2 V2 by V1 plus V2. Same formulas only will get as here. Okay, as usual formulas only will get ma. Now you got the clarity.
Yes, sir.
Okay, still anyone you having doubt?
No, sir.
Okay, so based on this one, tomorrow we are going to discuss the. Okay, so based on this one, tomorrow we are going to discuss some calculations, ma. Okay, so while coming tomorrow, just you read all the formulas, and tomorrow I'm going to complete this chapter. Got it?
Yes.
Will anyone you having doubt? So
No,
today
sir.
I'm going to forward some assignment based on these concepts. Better to practice the questions. If you're having any doubt, means we'll discuss in the next class. Okay.
Yes, sir.
Shanika, do you have any doubts?
No, sir.
Sriyuta?
No, sir.
So all of you understood now?
Yes, sir.
So then we'll continue in the next class. Thank you all.
Thank you,
Thank
sir.
you, sir.
Yeah, you pick up.